question please. Okay. Well, welcome back to our relations and functions. Let me revise yesterday's questions. There were 2 questions given to you. I would like to see whether it is done or not. If not done, I will help you doing. Question number 2 was to show that the relation R from n to n, R is equal to set of AB where A raised to B equal to B raised to A. You have to show it is an equivalence relation. What is equivalence relation? A relation that is reflexive, symmetric, and transitive. You have to show this relation R is reflexive, symmetric, and transitive. Okay, let me take up that. Those who have done it, just see how we have done it. Well, first of all, you have to show it is a reflexive relation. That means for every element A, it must be related to the same element. For A belongs to n, we must show that AA is a member of n. AB is a member of the relation, AA is a member of R. AB is a member of R if A raised to B equal to B raised to A. AA is a member of R if A raised to A equal to A raised to A. Oh, that is true. Obviously, A raised to A equal to A raised to A. That means AA is a member of R for all A in n and R is X. Okay, reflexivity is fine. For symmetry, AB is a member of R is if A raised to B equal to B raised to A. You have to show if AB is a member of R, then PA is also a member of R. Of course, this is again true, obvious. If A raised to B equal to B raised to A, naturally B raised to A is A raised to A. That means BA is a member of R. And hence, it is symmetric. The relation is reflexive and symmetric. Now we have to show it is transitive. For transitivity, what we need is that if AB is a member of R and BA is a member of R, then we must get AC is a member of R. We know when AB is a member of R, A raised to B is equal to B raised to A. When BC is a member of R, B raised to C equal to C raised to B. If we want to show AC is a member of R, we must show A raised to C equal to C raised to A. If we want to show AC is a member of R, we must show that A raised to C equal to C raised to A. Let us see how we get it. We have A raised to B equal to B raised to A because AB is a member of R. Further, we have B raised to C equal to C raised to B because AC is a member of R. Now from there, to get this, what I do here is I raise the power by C in this. A raised to B equal to B raised to A. I raise the power by C. So A raised to B whole raised to C equal to B raised to B whole raised to C. And here, B raised to C equal to C raised to B. I raise the power by A both sides. What is the advantage? When I raise the power by C here, I get A raised to BC equal to A raised to BC equal to B raised to AC. And here it is B raised to CA equal to C raised to PA or C raised to PA. That means A raised to BC and B raised to AC are equal. B raised to AC is further equal to C raised to AB, or ultimately we get A raised to BC equal to C raised to. Are you getting this point? I raised this by power C and I raised this by power A, and what this are raised, this is raised to power C and this is raised to power A. These terms are same and hence we get A raised to BC equal to C raised to AB. This is as good as A raised to C whole raised to B equal to C raised to A whole raised to B. What ultimately I want is A raised to C equal to C raised to A, that we are getting because raising the power by 1 by B. A raised to C whole raised to B equal to C raised to A whole raised to B. That implies A raised to C equal to C raised to A. And hence AC is a member of R, or R is transitive. Once R is transitive. And hence from 1 to 1, 3. 1 it is flexive, 2 it is symmetric, 3 it is transitive, then equivalence relation. The second question was here, a little more interesting, that A is a set 2, 3, 4, 5 dot dot dot. Verify whether the following relations are reflexive, symmetric, or transitive. If it is reflexive, symmetric, as well as transitive, it will be equivalence relation. You are asked to verify each of them separately. Okay, R is set of x, y where x and y have a common factor other than 1. Well, obviously, it is reflexive. Why? 2 and 2 have a common factor other than 1, which is 2 itself. So 2, 2 is a member of the relation. 3, 3 is a member because 3 and 3 have a common factor. X and Y, if they have a common factor other than 1, Y is a member. So AA will be always a member. Reflexivity is obvious here. So for reflexivity, we have for any A in A does not have 1 here. For any A in A, we know A and A have a common factor A itself. And A is not equal to 1. And therefore, AA is a member of R for all A. That is, R is reflexive. No doubt it is reflexive. Okay? Go ahead. You have to go on responding if at all I make any error. Well, for symmetry, AB is, I suppose AB is a member of R. You have to show that BA is a member of R. When AB is a member of R, we get A and B have a common factor other than 1. And now to show BA is a member, you have to show B and A have a common factor. Of course, when A and B have a common factor, makes no difference, B and A have the same common factor other than 1. It's obvious. So that means when AB is a member of R, A and B have a common factor, that will very much imply that B and A also have a common factor, that is BA belongs to R. So R is symmetric. Are you getting along? I ask again. Okay. Now we go for transitivity. AB is a member of R and BC is a member of R. That means A and B have a common factor other than 1. B and C have a common factor other than 1. Okay, I again ask, are you following?
Yes, sir.
Okay. Okay. Any question, you please respond immediately. Well, that means A and C have a common factor. Okay? Agreed? Hello? Hello?
No, sir.
Yes,
No
sir.
Yes, agreed? There be careful. Look at this. 3 and 6 have a common factor. 6 and 8 have a common factor. Do we have a common factor 3 and 6? 3 and 8? Well, what I said and you agreed is that if A and B have a common factor and B and C have a common factor, then A and C have a common factor. You agreed, but it's true. 3 and 6 have a common factor. 6 and 8 have a common factor. Do you get 3 and 8? No, it is not. It's not true. It's not true. Come on, I have to cancel all this. It is not true. Once it is not transitive, you just produce that. This is the answer. 3, 6 member of R, 6, 8 member of R, but 3, 8 is not a member of R. So R is not transitive. Are you agreeing? Be careful about it. I think the steps are clear here. I have written it purposefully to make you sure that you attend it very carefully. A and B have a common factor. B and C have a common factor. You are tempted to say that A and C have a common factor, but that is not true here because we have seen an example. 3 and 6 have a common factor. 6 and 8 have a common factor. So 3, 6 member of R, 6, 8 member of R, but 3, 8 is not a member of R. Hence, all those are gone. Our answer must be that example will produce that it is not transitive. So that was reflexive, it was symmetric, but not transitive. Okay, the last one among that was a reverse way. That is the set A. R is a relation set XY where X and Y have no common factors other than 1. Will it be reflexive? 2 and 2. If the 2, 2 is a member, if they have no common factor. Yeah, 2 and 2 have a common factor 2. 3 and 3 have a common factor 3. 3, 3 is not a member. If they don't have a common factor, then only it is a member. 2, 3 is a member, 2, 5 is a member, but 2, 4 is not a member. 2, 2 is not a member. Obviously, it is not reflexive. I'm not going for it. You can produce one example. Symmetry. What about symmetry? If 2, 3 is a member, 2 and 3 have no common factor. Naturally, 3 and 2 have no common factor. We can write the steps. I'm avoiding that step. What about transitivity here? A and B have a common factor. No common factor. B and C have no common factor. Can you bring a common factor between A and C? Come on, you think? Is it transitive? Again, the same answer, not transitive, because you can see 4 and 5, no common factor. 5 and 6, no common factor. But about 4 and 6 have a common factor, so it is not a member. When is it a member? When they have no common factor. 4, 5 is a member, 5, 6 is a member, but 4, 6 is not a member, so it is not transitive. Okay, it was a simple question I left for you. Now you can write the answer in detail there. We go for next question. This is a relation from, not from n to n, but it's from n cross n to n cross n. Remember, the domain itself is n cross n. That means domain itself is A cross B. So domain itself consists of ordered pairs. Codomain also consists of the same ordered pair. Instead of A related to B, I had to say AB related to CD. The definition given is AB related to CD. A plus B equal to B plus C. A plus B equal to B plus C. Well, the relation is, you can understand from here, it is not from n to n. Domain itself is n cross n. Codomain is also n cross n. 1, 1 is related to 1, 1, because you know the definition is that AB related to CD if A plus B, that is far ones and near ones, their sum is equal. A plus B and B plus C are equal. Understand it very carefully. 1, 1 is related to 1, 1. 1, 2 is related to 4, 5. I'm just producing some example for you. 1, 2 is related to 4, 5 because the sum of the far one, 1 plus 5 is 6, 2 plus 4 is 6. So the definition is that if AB related to CD, then A plus D will be B plus C. Well, I think the relation is clear now. We go for it. To show it is reflexive, you have to show it is not A related to B. You have to show AB related to AB. We have to show if it is reflexive, then AB must be related to AB. That is true. The sum of far ones, A plus B, sum of the middle one, B plus A, both are same. So reflexivity is obvious. A plus B. So look at the sum of far ones, A plus B and B plus C must be equal. And for AB related to AB, we have sum of far ones, A plus B and B plus A, they are equal. That means it will be reflexive. R is reflexive. R reflexive. AB related to AB is true because A plus B equal to B plus A. A plus B equal to B plus A is true. For all A, B belongs to n cross n. Domain itself is n cross n. So it is R is reflexive. Now for symmetry. For symmetry, it is very simple. AB related to CD must imply CD related to AB. Tell me, when do you say CD related to AB? CD related to AB, if the sum of far ones, C plus B equal to D plus A. CD related to AB is true if C plus B, that is far one, C plus B equal to D plus A. But that is obviously, when AB related to CD, you can read C plus B, that is here C plus B equal to D plus A, or the same thing. When AB related to CD, we have A plus B equal to B plus C. That is as good as. That is as good as. You can read the same step. That is as good as C plus B. That is C plus B equal to D plus A. When C plus B equal to D plus A, we get CD related to AB. C plus D equal to B plus A. So sum of far ones and sum of middle ones are equal. And hence we have CD related to AB. Whenever AB related to CD, that is a symmetry. When X related to Y, Y related to A. So AB related to CD, then CD related to AB. Hence R is symmetric, right? It is reflexive, now also symmetric. Now we go for transitivity. For transitivity, what do you need? If AB related to CD and further CD related to EF, you have to show that AB related to EF. AB related to EF means, to show AB related to EF, what do you need? Forwards. A plus F equal to B plus E. You have to show A plus F equal to B plus E. What is given? AB related to CD means A plus B equal to B plus C, and CD related to EF means C plus F equal to D plus E. A plus D equal to B plus C, and C plus F equal to D plus C plus F equal to D. You are to show A plus F equal to B plus. Simple adjustment. Simple. What I do here is that in this I had F both sides, and this I had B both sides. What is happening there? I am adding F here in both sides, F, and adding B in both the sides. What is happening ultimately? This is B plus C plus F. This also B plus C plus F. And hence what we are getting is that, look at A plus D plus F equal to B plus C plus F. That is as good as, that B plus C plus F is as good as B plus D plus E. What did I do? I simply added F in both sides here. I simply added B in both sides here. And these two are equal now. And hence you are A plus B plus F equal to B plus D plus. A plus B plus F equal to B plus D. D cancels, and you are getting A plus F equal to B plus C as you require. AB related to EF if A plus F equal to B plus E. Simple one, not highly tricky. And hence we have AB related to EF, and therefore R is transitive. So this relation is reflexive, symmetric, and transitive. Very clear? Let me just take, so hence it is an equivalence relation. Okay, it is an equivalence. Let me take just one example where I'm just testing you. Is it reflexive, symmetric, or transitive? A is equal to 3, 4, 5, 6, 7, 8, 9, 10, 11. R from A to A, R equal to set of x, y, such that y equal to 2x plus 1. Is it reflexive? Praksha, is it reflexive? Is 3, 3 a member? R is set of x, y, where y equal to 2x plus 1. Y equal to 2x plus 1. Is 3, 3 as a member? When x is 3, what will be y? Y cannot be 3.
7.
3 is not? Hello? That means 3, 3 is not a member. 3, 3 is not a member. When x is 3, y cannot be 3. That means it is not reflexive. What about symmetry? We have seen 3, 7 is a member. Is 7, 3 a member? When x is 7, can y be 3? It cannot be. It is not symmetric because 3, 7 is a member, but 7, 3 is not a member. But now my question is, what about transitivity? Can any of you tell me whether it is transitive or not? Pushti, can you tell whether it is transitive or not?
No, it is not. No.
No? Let us see. Transitivity, you understand very carefully. For transitivity, let us see what that R is. R has only 3 elements. 3, 7, 4, 9, 5, 11. Anything else? Any other element in the relation? Y is equal to 2x plus 1. 3, 7 is there. 4, 9 is there. 5, 11 is there. Now, can you tell me whether it is transitive? Vasu, you did not attend yesterday's. You should go through it.
Sure.
Yes, sir. I'll go through it.
Okay. Om, tell me, is it transitive? Presha, tell me, is it transitive?
Yes.
Yes or no?
Yes.
No, sir.
I hear both yes and no. Om, I think still telling no. Tell me why, Om? Or tell me, Presha, why yes?
Yes, sir, it is because there is no other relation. Like
Very good. The
Yeah.
transitivity is not violated anywhere.
Yes.
The transitivity is not violated. If you take 3, 7 and if you can bring 7 as a first element, then only you look into whether transitivity violated. Transitivity is not violated anywhere here. That is the point you have to understand. This relation is transitive. You understand? You remember? You refer that definition again. It will be, suppose I have one more element here. Suppose I have 7, 13 is there. Suppose 11, 12, 13. So sorry, 7 to 7, 15 is there. Then 3, 7 and 7, 15 is there. But 3, 15 is not there. You can say it is not transitive. So the same relation all depends on what set it is defined. With this relation on this set is very much transitive because the transitivity is not violated anywhere, and hence R is transitive. And understand very carefully when the relation is transitive, when the relation is not transitive. Yesterday we discussed a very good example. Actually, the question is from your textbook only. It is a very good example to understand what is transitivity and when it is not transitivity. Only when transitivity is violated, you can see it is not transitive. Well, we go with more problems. Please note down this question. Question 6 is, L is a set of all straight lines in space where R is a relation defined on N. R is equal to L1, L2, where L1 and L2 are two lines. Right? L1, L2, where L1 perpendicular to L2. I have not written L1 and L2 are two lines. L1 and L2 are two lines. They are related if they are perpendicular to each other. We can easily show. You actually claim the sentence. It is not reflexive. One line cannot be perpendicular to the same. It is not reflexive. And it will be symmetric. Why? If L1, line L1 is perpendicular to line L2, then naturally L2 perpendicular to L1 also. Transitivity, you have to tell me, it is not transitive. Again, 7 and 8 are from N cross N to N cross N. First one is dictated to the previous one. AB related to CD, AD equal to BC. Earlier one we had seen A plus B equal to B plus C. Here you are AD equal to BC. Remember, these are board questions. You have to take care. If you don't get, I will take up further. Again, question number 8. Little more complicated. Relation is on N cross from N cross N to N cross N. AB related to CD, AD into B plus C equal to BC into A plus C. If you get it, you do. Otherwise, question number 8, I will discuss when Monday. Now we are meeting back on Monday. Okay? Getting along? We'll meet back on Monday.